The constant rate of change and slope. Objectives to find the constant rate of change for a linear relationship and to find the slope of a line. The new vocabularies are rate of change, linear relationship, constant rate of change, and slope. The definition of the constant rate of change. A rate of change is a rule that describes how one quantity changes in relation to another quantity. In a linear relationship, the rate of change between any two quantities is the same or constant. This is called a constant rate of change. Example 1. The table shows the distance traveled on a zipline tour. Find the constant rate of change between the quantities. As we can see the table, it contains some information between time in seconds and distance in meters. The times increases by 2 seconds every time, and the corresponding distance increases by 4. The independent variable here represented by the distance. So the difference between any two consecutive values are 4, and the dependent variable represented here by times. Sorry, I think the independent variable is the times and the dependent variable is the distance, because the distance depends on the time. So the distance increases by 4 and the time increases by 2. To find the rate of change, we need to divide the difference between the dependent variable on the independent variable, or the change in distance or over the change in time. So change in distance is always 4 and the change time is always 2. So 4 divided by 2 is the constant rate of change. So the constant rate of change in this example is 2 meters per second. Example 2. It's a table shows the relationship between days and money earned per day or lost per the day. We can see that the days increases by 1 every time, and the amount decreases by 20 every time. And the constant rate of change is the change in amount divided by the change in days, or difference on y divided by the difference in x's, or the difference on the dependent variable divided by the difference on the independent variable, which is negative 20. So the constant rate of change is negative 20 dirhams per day. Example 3. A circular design on an online advertisement has 2 circles. One that is decreases in size and one that is increases in size. Find the constant rate of change for the radius of circle 1 in the graph shown. Then interpret its meaning. The first step is choose any 2 points on the green line. On the green line, we can see that we have 3 fixed points, here, here, and here. So this point is 6, 4. This point is 2, 5, and this point is 0, 5.5. Let's choose any 2 points such as 2, 5 and 6, 4. 2, 5 means that 2 seconds if the radius is 5 centimeters, and 6, 4 means 6 seconds for radius of 4 centimeters. 2, 5 means 2 seconds for the radius of 5 centimeters, and 6, 4 represents 6 seconds for the radius of 4 centimeters. The second step is to find the rate of change between the points. So the rate of change is the change in radius, or on y-axis. So the radius here represented by the y-axis. So change in y over change in time, or the x. So change in y, we have 5 minus 4 or 4 minus 5, depends. So if you start from 4 minus 5 in the numerator, you start from 6 in the denominator. But if you start with 5 in the numerator, you start with 2 in the denominator. So it doesn't matter which point you choose first to start, but whatever you choose remain, make it the first. So here he says 4 minus 5 in the numerator, and in the denominator he says 6 minus 2. So 4 minus 5 is -1, and 6 minus 2 is 4. So it's negative quarter, or negative 0.25 centimeters per second. So the rate of change is negative 0.25 centimeters per second, means that the radius of the circle is decreasing at a rate of 0.25 centimeters per second. Example 4. Find the constant rate of change of circle 2 in the graph above, and interpret its meaning. So we just found for the circle 1 that represents with the green line in example 3, and now we will use the same idea for the circle that represents by the blue line. So again, we will choose any 2 points on the line, such as 2, 3, and 4, 6. 2, 3 represents 2 seconds for the radius of 3 centimeters. 4, 6 represents 4 seconds for the radius of 6 centimeters. Step 1, we just did it. Step 2 is to find the constant rate of change between the points. We'll see where exactly 6, 4 here. Sorry, it's 4, 6. 4, 6 is over here, and 2, 3 is over here. So as we decided, we will take 6 minus 3 over 4 minus 2. So 3 halves. The rate of change is 3 halves, or 1.5 centimeters per second, means that the radius of the circle is increasing at a rate of 1.5 centimeters per second. And here is the concept summary of the rate of change. The rate of change is positive if the line increasing, and it's negative if it's decreasing. And it's 0 if there is no change or constant. And the key concept of the slope. The slope m of a line passing through points, any 2 points like x1, y1, and x2, y2, is the ratio of the difference in the y coordinate to the coordinates difference in the x to the corresponding difference in the x coordinates. So the slope m, y2 minus y1 over x2 minus x1, And we have learned that the denominator shouldn't be 0. That's why x2 cannot be equal to x1. So the slope is the ratio of the vertical change to the horizontal change of a line. It describes the steepness of the line. In linear function, the slope or rate of change of the line always constant. Steeper slopes represents greater rates of change. Less steep slopes represents lesser rate of change. So we just learned that the slope concept is exactly like the rate of change. Example 5. Find the slope of each line. We can see that the line in graph A contains two fixed points, 4, 3 and 8, 6. So we will just subtract the y values and we divide it by the difference in the x values to find the slope. So we'll say 6 minus 3 over 8 minus 4, and that's it. Or y2 minus y1 over x2 minus x1. If we called 4, 3 the x1, y1, and 8, 6 the x2, y2, so y2 here represented by 6, and y1 represented by 3, so we'll say y2 minus y1 or 6 minus 3 over x2 minus x1, which is 8 minus 4. 6 minus 3, 3, 8 minus 4 is 4, so the slope is 3/4. B. The fixed points are negative 4, 2 and 2, negative 2. So if we choose 2, negative 2 to represent x1, y1, and negative 4, 2 to represent x2, y2, so I'll subtract y2 minus y1, or 2 minus negative 2, divided by x2 minus x1, or negative 4 minus 2. So 2 minus negative 2 is 4, and negative 4 minus 2 is negative 6, to be simplified to negative 2/3. C. He gives us 2 points, A and B. A is negative 4, 3, while B is 1, 2, and he wants us to find the slope. So we will subtract y2 minus y1. So y2 here is 2, and y1 is 3, so it's 2 minus 3, divided by x2 minus x1, and x2 here is 1, while x1 is negative 4, so we'll write in the denominator 1 minus negative 4. 2 minus 3 is negative 1, 1 minus negative 4 is 5, so the slope is negative 1/5. Example 5, B. Find the slope of the line that passes through each pair of points. A, negative 3, 4, B, 2, 4, and I just recognized that the y coordinate here is the same, so it's 4. So it represents a horizontal line that contains or passes through points A and B. If we need to find the slope, we will subtract 4 minus 4 divided by 2 minus negative 3, or negative 3 minus 2, depends on your choice. But the slope is always 0 because 4 minus 4 is 0. And the slope of any horizontal line is 0. Let's see what about the vertical line. The vertical blue line in the graph passes through points T and U, 1, 3 and 1, 0. So if we choose 1, 3 to be x1, y1 and 1, 0 to be x2, y2, so y2 here is 0 and y1 is 3. So the denominator contains 0 minus 3, since the denominator contains 1 minus 1. 0 minus 3 is negative 0, and 1 minus 1 is 0. So -3 divided by 0 is a known value. That's why the slope of any vertical line is undefined. Thank you very much for watching.